Very excited today to offer you a webinar on solar power and battery-based systems for remote telemetry. We have two excellent presenters today, Charlie Bachman, Senior Sales Executive with SunWize Power and Battery, and Nick Krachmalnick from PCE Pacific. Charlie's expertise is in remote site, battery-based solar power systems and equipment for industrial applications in oil and gas automation, telecommunications, and general instrumentation. Nick, from PCE Pacific, who's holding a Yagi antenna, is a champion in the field of remote telemetry. He is a Delta V process control systems application engineer with expertise in radio and wireless solar power systems and RAS ROC. He has over 35 years of experience in telecom, SCADA, telemetry, using radio, microwave radio, wireless Ethernet, work system engineering, implementation, testing, and troubleshooting. Thank you, Charlie and Nick, for presenting this discussion. Today, we're going to cover why telemetry is core to the efficiency of applications that are communicating critical data from the field, along with an overview of our power systems, a range of telemetry options, and then showcase a few project examples. We look forward to your questions, and we'll address these mostly in the Q&A following the presentation. Before we get started, you will be in listen-only mode during the presentation. Please use the questions box on your dashboard on the right side of your screen for submitting questions throughout the webinar. Okay, Charlie, can you give us a little bit more information about SunWize Power and Battery?
Sure. Hello, everybody. Thanks for showing up. We'll make this worth your while here in the depth of the information. With SunWize Power and Batteries, we develop and manufacture solar electric and primary power backup systems. And this, I'm going to show you, this is our pre-engineered product line, and it's designed specifically with industrial applications and built to your requirements. So the Power Ready, there's three families. There's three systems here, or three categories of systems. Small and large for the solar, and then for the battery backup is Power Online. So the Power Ready is for the smaller loads. It's standalone, it's always solar only, and for the smaller power requirements. And then when it gets to a certain size, you can't put the array on top of the roof, the battery box gets big, we integrate this into a skid, and that's our power station. And this can be for solar only, and it can also, we can hybridize that too with gensets and other secondary sources of power, but it's for the larger power requirements. And then the Power Online is for the primary power backup, and this would cover a wide range of power requirements. It just depends on what your load is and how long you want to back it up. So we're here to talk about telemetry. And telemetry is it's a great topic because when you talk about solar systems, it's a remote application. And if you're designing sensing, data recording, all these applications that are out in the middle of nowhere, if they're out in the middle of nowhere because you're not there, so to get the information back to you, that's telemetry. There's a lot of options involved in telemetry, and the key is that it's critical to all of our applications. Almost no matter what we're doing, telemetry is at the heart of that to allow it to function in the way you want a remote monitoring and control system to function. So Nick's the expert here, and he's going to define the available technologies out there. So when you are looking at the options you have to put your systems together, you can pick the best one for the most efficient, for the most cost-effective for your application. So Nick, I want to thank Nick for being with us today, and let me tell you a little bit about him. I've worked with Nick for many years, and very excited to introduce you to him today. Nick, the way Nick and I work is he's defining as PCE Pacific and his array of equipment that's available, and Nick being the champion of telecom, he's defining this equipment, this monitoring, control, telemetry equipment package, that once that's defined, I can take that and and distill the power requirements from that particular package. And that's the basis for developing the right size array and the right battery, in essence, the right power system to meet your power requirements wherever your site happens to be. At PCE, Nick's the champion of telemetry and telemetry-based systems. He's the go-to guy. So welcome, Nick. Let's start with your high-level overview of PCE's capabilities.
Okay, thank you very much, Charlie, and welcome to everyone who took time out of their busy day to join us today. PCE Pacific is an Emerson local business partner for Emerson Process Management, and they represent Delta V, Fisher, Rosemont, Micromotion, and additional vendors like SunWize Power and Battery, various radio manufacturers, and other Emerson products. And as Charlie mentioned, we've been working with SunWize for quite a few years now, and in the process have learned how each other works and what makes a successful combination and what satisfies the customer the best. So again, it's been great working with Charlie all these years, and we look forward to a lot more successful years of working with SunWize and PCE together to solve customer problems and provide power to those locations which are otherwise either prohibitively expensive to get to provide power, and otherwise provide the reliability that of the power that's needed for critical applications. Charlie, back to you.
Yeah, thanks, Nick. So after Nick's going to determine what that equipment package is necessary, the next question that comes in is where's the power going to come from? And being a solar electric power company, we see situations that are far out. They're out there where sometimes roads aren't even, or they're out there where just there's no way utility power is going to get to the site. But because the decision is economically, where you get your power is going to be economically driven. So the first question is, how close are you to utility power? So there's all kinds of situations that you get involved in. The next slide portrays the rugged conditions, the rugged nature of most of these application sites. I mean, they can be severe winters, and they can be very far north. But just because they're very far north doesn't mean we can't design a power system. The solar array is just a little bit larger. It's tilted a little bit tighter. The battery's a little bit bigger because it's colder. But once we know that site location, we can design for that. And then, of course, when you're on a mountaintop, there's no delivering fuel for a generator or trenching in utility power. So challenging environments are almost always involved, in the more extreme locations anyway. So the applications, what we're looking for, number one is reliability, because it's not just the power when the sun's shining or in the summertime. It's the power right through the worst case conditions of the year, and it's 24/7. And number two, want to minimize the expenses involved in operating this system. Number three, you want it within a period of time to meet your project expectations, the commissioning timeline. So a complete pre-engineered power stations is necessary to achieve all these requirements. It needs to be thought through right from the beginning, from distilling the loads into a size of power system, and then building the power system itself to be easily installed and rugged enough to take the environment and designed to operate for many years. So back to telemetry. That's the core of our conversation for today. Nick, tell us what telemetry can do for us.
Okay. So why remote telemetry? Why would you need something like this? Well, the first thing is reliability, as Charlie just mentioned. You want to be able to catch any potential problems before they become expensive to fix, as well as having the power there reliably and consistently. You would like to know, I would think, what the current usage is, whether it's you're getting enough sun due to maybe snow on the top of the array, or other reasons, the overall state of charge of the battery bank, and you want to be able to alarm on those things so that you do get notifications so that when you're in a critical portion of your operation and you need the remote device to be giving you information, that it will be able to do that for you. Also having temperature alarms on the equipment, and the solar array will also give an indication of what is going on out there, and alarming for faults in general would help. In some cases, it's helpful to have video surveillance out there if there's a fear of vandalism or otherwise trying to determine what's going on and why you're not getting the readings from the remote location. With respect to generators at a remote site, using solar arrays, you can reduce the amount of time that the generator is running. And that saves you money both in fuel costs as well as maintenance costs, which are usually based on the hours that the generator is running, and extends the generator useful life. Also, by knowing what's going on at the remote sites, you can hopefully reduce the number of trips to the remote site that you need to make for preventive maintenance and other things, as well as bring the right equipment with you based on the conditions that you're seeing. If you need to bring a particular piece of spare parts or particular tools to do a specific preventive maintenance, you'll know exactly what you kind of need to bring with you. So ultimately, optimizing your on-site plan visits and bringing what you need. In covering the telemetry options, to bring the data back to where the data will be used, we'll start with closer distance to where the remote site is between the place where the data is used and the remote site, less expensive and lower bandwidth, and gradually progress through the options to show more of a distance in between the methods that are available to do that, as well as higher bandwidth and generally a little bit more costs involved. And a comparison chart after the options will summarize what we cover in the way of telemetry options. So starting out with what you existing infrastructure, or another way of saying that is, what do you have on your facility today that you could potentially use to bring back remote data? So starting with hardwire, depending on the wire characteristics and what you're trying to do, in some systems you can get up to about 19,000 feet using RS-422 serial data, shorter distances, RS-485, Modbus, and RS-232. And those are with existing wiring that you have on site today. Moving up the chain in bandwidth a little bit, we have our Ethernet, Cat5 and Cat6 copper. Distances there are anywhere from 100 meters, about 326 to 28 feet for the Cat5, and for higher bandwidth up in the gigahertz, you can still use copper, but the distances overall are shorter. And the next thing, moving a little bit higher up the bandwidth and distance chain, would be fiber optics, which if you happen to have on site, generally there are two types of fiber optics. One is called multi-mode, the other is called single mode. Multi-mode is generally for shorter distances, usually just under a mile. And those are characteristically used between buildings. Fiber optics has a lot of benefits in that, number one, it provides very high isolation. It doesn't conduct electricity. It does conduct light pulses. And you are not going to transfer electrical noise from one building to the other, as well as you're not going to be able to run electricity across it. So it provides very high isolation, and that's the reason that people use multi-mode. In addition, the other reason that people use fiber optics in general is that if you do need more bandwidth at some point down the road, the only thing you really need to do to get more bandwidth out of a fiber is to change the electronics on both ends, because fiber has virtually unlimited bandwidth. Once you get into higher and higher bandwidth requirements, the electronics on both ends gets to be quite pricey. But it is in the ground already. It's running in between your buildings, so you've already saved a lot of money by using what's there already. Adding in an additional run to bring in a remote location that's a little bit farther out, depending on the terrain, could be either not too expensive or quite expensive, depending on how far away you're talking about. If you're starting to need further and further distances, then single mode fiber is what is normally used because it can cover anywhere from 50 to 75 miles without needing additional amplification. A lot of people use single mode fiber on site, even though it's not necessarily required for what they're doing, but that's a preference that you have. They may already have single mode fiber on site, or in a greenfield application, that's what they decided to use to start with. Next slide, please, unless there's questions on this one. Moving a little bit farther up the chain, in the last slide we talked primarily about serial and Ethernet bandwidth. If you're talking a little bit further out on distances now, you can look at VHF and UHF radio, or 150 to 900 megahertz radio. These are used in various different kinds of network. P2P is a point-to-point, which basically, if you look at the diagram in the lower left-hand corner, you take the middle unit and either the one on the right or the one on the left, and that would be a point-to-point circuit. So basically, two ends to transfer data, and data can be anything from serial data at 115 kilobits per second to even higher at almost 1 meg. Point to multipoint would be as the diagram shows, and that would be the middle unit would be the master radio, and the two units on either side, or it could be a lot more than two, because it is a multi-point system. You can kind of visualize this like a bullseye, with the center of the target, the master, and the slaves scattered around in the outer rings away from the bullseye, with everybody talking to the master radio. To the right in the picture, that shows a telemetry array with a 900 megahertz antenna on it, and it's a little weather station there and a couple of other environmental monitoring things. The 900 megahertz and also 800 megahertz is used in the oil and gas industry quite a bit to bring in wellhead data back from the field back to a central location through the master and onto a server, so that when the owner of the company or his operations staff on the East Coast want to know, well, how much gas is being produced by this particular gas field, all they need to do is go over the internet to access the server where all this data is being stored. And it gives them reliable data and near real-time data that they can manage and make efficient operations and make command and financial decisions based on the information that they're seeing. You also have Wi-Fi radios that normally can be running in a mesh network or variations of either point-to-point or multi-point. A meshwork is kind of like a fishnet, with the outer edge of the fishnet being the definition of the territory, and where all the strands on the fishnet come together would be access points. And these access points generally run either 2.4 gigahertz for the people running around with laptops and other Wi-Fi type devices, and they have a 5.8 gigahertz backbone that the various nodes or the various points, the interconnection points on a fishnet, communicate back together with and form a mesh. Other instances of mesh would be a low-powered sensor network talking back to a gateway, and then the gateway would, by several different means, either Modbus 485 or OPC or Ethernet, get that information back into the control system so it knows what's going on and includes that information as part of the loop control that they're doing in the process industry. There are other examples, including pipelines and water, wastewater, and to control remote valves and pumping stations and lift stations, just depending on the system. So, and VHF, UHF radio can be either licensed or unlicensed. If you have licensed radios, then you need to get a license from the FCC, fill out some forms. Licenses are generally good for about 5 years or so. And the unlicensed frequency, basically everyone has access to, and it's normally better if you can coordinate with people on site as to what channels or frequencies you're using, rather than everybody fighting everybody else and the resulting data slowdown as contention for channel space arises. Next slide, please, unless there are any questions on this one.
Yeah, I think that's...
Nick and Charlie, we do have one question here. It says,
okay.
What is your option, if any, on Zigbee mesh network hardware? Thanks, Mike.
Okay, on mesh network hardware, there are a variety of vendors out there that provide that type of system. I guess it depends on whether you're talking about sensors or just Wi-Fi in general. Cisco has a mesh network. Meraki is another company that makes mesh networks, basically using a Wi-Fi type infrastructure. If you're talking about sensor networks, Emerson has a mesh low-powered sensor network. They use 802.15.4, which is wireless HART. There are other systems that use ISA protocols instead to accomplish the same thing. There's also Zigbee, which is another format. It's a little bit higher power to bring in your mesh networks, and a lot of these low-powered networks are self-forming. So basically, once you program in a join key and a network ID, as in the Emerson system, which I'm more familiar with than the others, you basically put the unit out there and you tell the gateway to advertise itself. And it says, hey, anybody out there with the right information can connect to me. And it goes ahead and basically the whole network rearranges itself as you add additional sensors to make for a stronger network. I hope that answers your question. All I'm saying is if you look up mesh networks on Google, you'll get quite a few responses from a variety of different vendors.
Great. Let me ask you one more part to that question. Are there any known CS PAC bus to Zigbee or other 900 megahertz conversion modules out there?
Can you say that again?
Are there any known CS PAC bus to Zigbee or other 900 megahertz conversion modules out there?
I am not aware of any off the top of my head, but a little bit of research could be done. I don't know of any for Zigbee in particular off the top of my head, but I know that the standard Wi-Fi formats are supported. All the 802.11 A, B, G, N, AC are supported for mesh networks, and also the low-powered stuff at 802.15.4 are supported by several different vendors. Phoenix is one company that does that. There are others as well.
Okay, great.
Okay.
Yeah, I think that's good. Thanks, everybody, for sending in these questions. This is great. As we go through this, we can address these when they're more appropriate. Thank you.
Okay, moving up the chain in distance and bandwidth and cost, take a look at microwave radio and free space optics, otherwise known as laser communication. The microwave tower that you see in the top picture, that's used for long-distance communication. This is a hub from multiple different directions coming in here. Years ago, Ma Bell used to use microwave hops for all of their long distance calls. That was before the satellite network went up, and it was very reliable. Microwave distances vary with the frequency. It used to get 15 to 20 miles, but the FCC changed that around a little bit when they took back some of the frequencies for some of the specialized mobile radio licenses like Nextel when they came out. But in any case, microwave, you can get several hundred megabytes, even up into a little bit higher than that, depending on the system. And it's very reliable. If your company has a microwave system already, it would probably be not more expensive, not too much more expensive, in order to add a hop if it's not too far away, in order to get to your remote location, if that is critical enough to justify the cost involved. There's a little bit of RF engineering involved in that. And also, even if your company doesn't have a microwave, but there is microwaves near where you need to be, you may be able to get onto that system by talking with the owner of that system and be able to share a little bit of bandwidth. There would probably be a monthly recurring charge and perhaps a connect charge as well, but it just pays to look around and see what's around close to where you need to get the information from in order to get it back to where you need it to go. Below that is a free space optics or laser link. These are usually very high bandwidth but very short distances, characteristically about 300 feet. So you say, why would you need that? Well, if you're in a situation where you have a satellite building across the street, across a roadway, especially located in a downtown or a urban environment, the time it would take you to get the permits and the access to dig could be anywhere from 6 months to a year and be quite expensive. So you have the option instead of putting a couple of lasers, one across from the other, and that will give you approximately 1 gigabit of data, of actual data, flying through the air. And the only thing that's really going to affect it is fog. So as a backup, what people do is they stick a microwave link right side by side with a laser link. And so if it's really foggy, the laser is affected, and if it gets foggy enough, it'll drop out. But you have a failover set up to where a microwave link picks that up. And so you might drop down from a gig to 300 or 400 megabytes, but you don't lose that capacity and getting the information across the road. I've seen this type of application usually in hospitals where they're sending MRI information, MRI imaging across to a satellite building where that imaging will be processed before the doctor gets to see the results of it. Any questions on this? If not, we'll continue to the next slide, please. Cellular, of course, is always an option, depending on whether or not you have coverage or not. You can put in a cell modem, and that'll support serial as well as Ethernet. And if you're in a fringe area and just barely have enough signal to get by, there's a couple things you can do. One is you can take your cell phone out there and see how many signal bars you have. There is a free web application called Cell ID for Android phones, and I'm sure there's probably more than just one, and an equivalent for iPhones, that will let you know by using the application the latitude and longitude of the cell site you're connected to, as well as that will give you the physical location, and it will also give you who the service provider is and some other more detailed information about the cell site that you happen to be connected to. Now, this is if you have more than one bar. If you have a couple of bars, if you only have one bar, you might want to walk away from the site till you find out where you can get a couple of bars of signal at. And so once you are able to use this application to locate the latitude and longitude, you take this over to Google Earth. You plot it out by putting a stick pin there. You put your cell site or your location where the remote terminal is, and you put that on Google Earth with another stick pin. Then you take the little measurement tool, which is a ruler in Google Earth, and you draw a line between where your remote site is and the nearest tower. And in some cases, you can put an antenna on your remote location to gather as much signal as possible and maybe increase from 1 bar up to 2 or maybe even 3. And that will be enough to establish a link and be able to uplink your data. Various things on the cell modem. They also have alarm contacts, so you can get like an intrusion alarm if somebody opens the door on the building that the equipment is in. So at least you get some notification in addition to the raw data that's coming from the site itself. These type of things are done on a contract basis, just like your cell phone, with the cell phone provider. And it's paid for by the amount of data you're using over a year's worth of time and the length of your contract. And generally, the people that sell the cell modems, 6Net comes to mind. ProSoft Technology is another company that sells these cell modems. Once you let them know what the service provider is doing, they will have a cell modem that would be compatible with the service provider's system. And so that way, you'll be able to get coverage, get information back, and worst case, if you can't get any signal out there, but there is a spot within line of sight that you can get a signal at, what you can do is uplink using a radio at your remote location, which is not in the cell coverage, to uplink data to another radio at the location where you do have cellular coverage, if there is line of sight. And that's another way to skin that cat and bring the information in order to get it up onto a cell network and then over the cell network to its end destination, wherever that might be. If there's any questions on this, if not...
yeah, Nick, would you please repeat the name of the app again?
Yeah, it's called Cell ID, C-E-L-L-I-D, and it's in the Google Play Store. I just picked that one because I happen to have an Android phone. If I had an iPhone, I'm sure there's more than one out there to do that with.
Okay, great. And then we have another question. Are the bars on a cell phone typically showing voice connection or data? I've had occasion where we have not seen voice coverage but had sufficient data coverage for small data packet transfer.
Characteristically, the signal strength is shown in bars. And basically, what happens is you need a certain level of signal strength in order to get a bar of signal, or 2 bars, or 3 bars, or 4 bars. However, that doesn't mean that you don't have a connection. You might be able to get some data through there at a very low data rate. So if you have a large bunch of data to send or receive, it might take a while. But you still might have enough coverage in order to do that. I guess a bigger indicator would be what the signal-to-noise ratio is along the path between the cell site and your location. So yeah, that can happen, but usually you need about a bar in order to have enough signal there to get sufficient data across so that you're not standing there for hours waiting for a certain amount of packets to download. Does that answer the question?
Yeah, great. Thank you.
Okay. Well, let's move on to the last option that I'm going to present today before the comparison graph or the comparison slide. That's satellite data telemetry. Satellites are great in that you can generally, unless you're underground, and if you don't have a visibility to the southeast sky, that's about the only time you really can't use them. So you do need visibility to the southeast sky, and the satellites are in geostationary orbit about 23,000 miles above the Earth. And you can visualize this as an old large record, like a record player, where you have a large LP type record, and you put the one dot in the middle where the spindle is, and you put a dot on the outer edge. Regardless of how slow or how fast it's going, the same point is always visible between the spindle on your record player all the way out to the outer dot. That's how you can kind of think about the constellation of satellite communication satellites that's up in the air. So you pretty much have coverage if you can see the southeast sky. These type systems are similar to the cell modem in that they'll take Ethernet and other things as well as alarm contacts, and they'll upload that information into the satellite on a schedule that you can customize and modify. So depending on how much data you need when, if it's stuff that's not changing very much, you might do 1 or 2 uploads a day. If it's stuff that's more critical than that, you could upload every 5 minutes. The more you upload, the more data you move, just like on a cellular plan, the more you're going to pay for that time. The telemetry is uploaded at the remote site, gets up into the satellite, and the satellite network connects to the downlink, and then from there you can access it over the internet. You can get it routed to wherever you need that information to go. It's very similar to cell phones in that there is a monthly recurring cost. A little bit of site engineering is required, and you can talk to a satellite data provider. There are various ones around the country. I don't know of any in my particular area at the moment, but I have not had to avail myself of that. The other great thing is if your company has multiple national representation, this solution is good all over the earth pretty much. Any questions on this? If not, here is the first part of the comparison slide. So recapping a little bit, we have the existing infrastructure, or what's on your facility today, or what can you get access to locally. The hardwired, pros and cons, good short distance solution. The con is limited to short distance, serial 422, Modbus 485, or RS-232. The Ethernet options are there with distances from 326 feet or less. A little bit more expensive than the hardwired, especially if all this stuff is already existing on your facility today. And the fiber options, which could also be existing today. Advantages of the fiber is more Ethernet bandwidth, virtually unlimited Ethernet bandwidth, depending on the electronics. High isolation, no noise, and generally a good solution for on-site in between buildings. Cons are it's expensive to dig and trench new. You need permitting, you need some skilled labor to terminate that fiber, and multi-mode is limited to a little bit less than a mile. A little bit more expensive than a Cat 5 and Cat 6. Single mode, same thing as multi-mode, except you go greater distances, slightly more expensive, and because of the greater distances, you'll have more installation costs and termination costs. Skilled labor is still needed. Next slide, please. And now we'll talk about the recap of the radio, cellular, and satellite solutions. VHF, UHF radio, good solution, out to about 20 or 30 miles. In some cases, you can go a lot farther than that if your antennas and you have really good coax. I've seen some of these that can go up to 60 miles with 3-wave radios, for example. It does need some good RF engineering. The radios themselves aren't that expensive, but the terrain in between the two or more locations that are trying to talk to each other is what will increase the expense, especially if you have to stick a repeater in between to get over a hill, because unfortunately the radio signals are not going to tunnel through the hill. Next down is microwave and free space optics, good high bandwidth solution in both cases. For a little bit longer distances with microwave, you can get a whole system that'll march across a whole state or more. For the short distance, very high bandwidth, you have the laser optics. A little bit more expensive because now you're talking towers, construction crews, so on and so forth, if this is not available to you already, or a system near enough that you can get on it. And the cost depends on the site and the terrain around the site and where you need to go to be able to jump onto the system. Cellular, good solution if coverage is available. Pretty easy to check with your cell phone. And need cell coverage would be the con, or close by recurring costs. Costs are variable. You have the usual monthly recurring costs that you would have with any cell phone with a cell modem. And the cell modem itself is not that expensive, comparatively speaking. And the plans are based on data volume and the length of term of the contract and whether or not you need a radio link to get to a place where you can have coverage. And on the satellite, the pros can be deployed almost anywhere except underground or someplace where the southeast sky is blocked. There is some latency involved. We're talking about 500 milliseconds, about half a second. And in some applications that's important, in some applications it's not. In some applications where it is important, the satellite transponders can do a store and forward so that the end user at the downlink, end of the downlink, will not get interrupted and basically not be able to see that latency because it's compensated for at the satellite transponder. Costs vary depending on the same things as with cellular, the volume of data, the term of the contract, etc. That's kind of a recap of the various telecom options that we've presented today. Are there any questions on the comparison chart?
Yes, we have one. Is GOES something available for private use at all?
I have not investigated GOES. I know that there is a Russian group of satellites up there that put up by the Russian system as part of the new GPS system, and there's the existing GPS system, and there's existing data systems. I am not knowledgeable as to whether or not that particular system is available for private use. It'd be worth looking into, though, if you have coverage, or if you should have coverage with that.
Great. Thank you. Thanks, Nick. Thanks for all these questions, everybody.
Yep. And see what the next slide is here. I guess it's, again, thank you very much for your time. And a little bit later on in the presentation, I'll be talking about one application which kind of uses several of these technologies together to form the solution. So along with the reliable and powered engineered solution from SunWize. So with that, back to Charlie.
Thanks, Nick. So back to the power supplies. And everything that Nick has been talking about, all these technologies, the associated equipment, all that defines a certain power requirement for the certain package that you deem perfect for your particular application. So, and that's what the power design is based on. Knowing your load and then designing a power system that always keeps ahead of that load, has enough power. So just as reviewed, the three pre-engineered power groups that we have here, the Power Ready, that's a product line that takes care of the smaller loads. Standalone solar, it's the lower loads, generally up to about 100 watts of load. And then the power station, once you get bigger than a certain array and a pole can go, or it comes on an erector set, then we go into skid format. That's the power station, and we take that from 100 watts on up. And then the power online is when you have primary power available and you have that source. You deem that to be more economical, but you still need some reliability on that particular source of primary power. So, you know, you think of this, Nick's equipment is going to have a range. It's going to be 12, 24, 48 volts. It could be AC, you know, there could be a valve control operating at three-phase, 220 volts, or whatever that power concern is. That's our job to create that off the battery bank and to have in a solar array the proper size to keep the battery bank charged. So there's a lot of detail involved in that, but just know that small load, medium, large loads, or if you have primary power, it's defining a set of power conditions that we can meet. So that's fine, and I can go on and on about all the detail that involves in doing that, but really it comes down to once your package of loads is defined, it's best to have the discussion. have a real-time discussion to make sure everybody's on the same page in what's necessary, and I have the proper information on the loads to convert that into a power station. So that's fine, but there's an underlying question there saying, okay, yeah, well, solar's there, but the sun doesn't always shine. You know, what everybody says on it. There might be a hint of how do you know it's that reliable, and that's what I need to get underneath. And I want to explain on the next slide. Just why do you have confidence in the reliability of a solar electric power system or a hybridized system, and what is it based on? So here are the factors on why it is, how we can say absolutely that it's reliable. So once we know the geographical location defines how much sun is getting through the clouds at your site location. We know, and once we know that, that's a big piece of the puzzle. Number two is to define the power requirements. What are your loads? Because that's a finite amount that we can define. And the closer we define that, the more reliability is inherent in the system. So back to geographical location, we know on the outside of the clouds, there's always 1,000 watts per square meter. Wherever you are on the Earth, the sun is shining outside the cloud. Now, through weather data that's been collected over 20-plus years by NASA and NREL and weather stations, you know, there's government agencies, all this data has been crunched into our sizing program, so we know what that cloud cover is. And once we know how much sun is coming through the cloud cover, that's easy to define through a certain size solar array, how much power is available to put in the batteries. And that's the essence. And once that's balanced, once we know we can provide more power in a certain situation than you're going to need, now the batteries are always charged, that's where the absolute reliability comes in. And that's put together with the right size wire and the right size connectors and the breakers and the safety equipment and the controllers and inverters and DC to DC. All that equipment is pre-engineered into these different packages for your small loads on up through the big loads. So that's that. Happy to talk more about that.
So Charlie, I just wanted to ask you this question before we get into the examples, and they're very cool, and they're coming up here. Are some inverters more efficient than others with respect to DC to AC conversion? What sort of loss can one expect? And what solar charge controllers do you recommend you spec? And we did a webinar on controllers, which we will send you a link to that. But Charlie, do you want to?
Yeah, well, the first part of that is what's the efficiency range on inverters? Are some more efficient than others? And yes, that's the simple answer. The inverters, when commercial applications really came into being, that technology took off, and the quantity of the demand on that, I mean, mainly the home systems that came in, the grid tie, that was that technology when it came in, that developed, and it allowed us to it allowed these companies to give options for industrial type applications. So the efficiencies can be as high as 93, 94%, and depending which inverter that is chosen for the application, you can get down to 80%. You know, there's some options that allow the inverters to drop into standby, waiting to sense a load to come on, and so it goes on from there. But yeah, there's a big range. What was part two of that?
What sort of loss can be expected?
Yeah, there you go. Right, basically from 80 to about 94%.
Okay. And then there's a really great question you guys might want to talk about now, or maybe at the end here. I don't know. Is there a rule of thumb or set of guidelines when determining a power budget?
Well, the cost of these systems on the power side is proportional to how big that load is. So yeah, there's some rule of thumbs. But let's use that as a wrap up when I'm sure the other questions on costs. But I want to make sure that Nick gets in here on Nick. Let's talk about an application that we've worked on together and has been. It's what everybody's wondering. You know, what have you done, and is it still out there, and how is it operating? And, you have some great examples of where you've been.
Okay, thank you, Charlie.
Yeah.
The recent application that we've done is at a gold mine in Nevada, and the application was basically wireless control and monitoring of a mine dewatering system. So the purpose of the dewatering system is to keep water out of the underground portion of the mine, reuse the water where it's needed by the process, as well as irrigate farmland after the water has been treated, and prevent water spills by balancing the various sources of water being routed into large plastic pipes across the mine, because if they spill water out there, they get fined by the Bureau of Land Management, and that can be quite expensive. This area is in the high desert area of Nevada. Basically, very hot summers, and well in excess of 100 degrees, and very cold winters, sometimes down as low as -40. There are 3 main areas that we did, approximately 60-some remote sites. Some were DC powered, some were AC powered, and total coverage of about 167 square miles. There are several different methods being used to retrieve the data. What it was is there were 3 different areas. There was a redundant master in each area, and it was all Allen Bradley. So control logic 5,000 redundant controllers at each master, and out in the field was 1734 point I/O from Allen Bradley, and that was being interfaced into various sensors, so basically pressure, flow, various type sensors, as well as valve control, and in addition to that, there were some VFD pump and motor controls as part of this to pump the water, et cetera, move it around. Plastic pipes were used anywhere from 12-inch diameter to 48-inch diameter. And all of the remote sites, most of them had power because they were located near pumps and motors, but 13 of them did not. And because of the location, it was cost prohibitive in order to provide power to these sites. So what we did was we used the SunWize solar arrays to provide power. The load out there was 4.8 amps, and 80% of the load was DC heating. If you look at the picture on this particular slide, you can see that the solar array is tilted toward the sun, of course. The big white box underneath it is where the batteries are. The little box farthest away on the other side of the battery box is where the Morningstar charge controller is located. And the large box in front of it is where the Allen Bradley I/O. In addition, there was a static switch in there, as well as ProSoft radios, and this was part of a Wi-Fi network using 802.11n to make a mesh network that went back and provided that data to the Allen Bradley controllers, which in turn sent that information to the control room. So many of the sites had fiber optics already run to them. Some of them were close enough to where they could use Cat5 or Cat6 copper cable. And there were none close enough to use the hardwired solution, but we were able to use the combination of the radio as well as the Wi-Fi radio as well as the fiber and the copper in order to put the whole system together. The system has been running out there about 3 years now. We've had no issues except for initially. Initially, there was a problem when the on-site contractors wired up the battery bank for 80 volts instead of 24, and the equipment, of course, didn't like that very much and burned out right away when it was first hooked up. So that was about a $10,000 mistake equipment-wise. But other than that, these things have been running for 3 years of summers and winters in the high deserts in Nevada, and been very happy with the system. There were some initial antenna alignment things that we had to get worked out. I was out on site working through some issues out there. The only other issue we had was operations decided that they were going to stick a leach pad in front of one of the master sites, so blocking all the antennas. So we wound up having to go down about a mile or two, put up a 100-foot tower, and create kind of a new master with a separate control link back to the old master where the control logics were located. Other than that, it's been very reliable and working and doing the job. And so moving the water around so that they're not getting fined, and instead it's being used for farm irrigation. The white stand, by the way, underneath the array serves two purposes. The first being to keep it out of the snow, because it does snow quite a bit up there. The second, and almost more important purpose, is it gives the cows something to rub against instead of rubbing against the solar arrays, because there is cattle in the area and some active cattle farming is going on. The pole, kind of in the middle of the picture, is where the antenna is located. You can see what the area looks like. It's pretty flat, pretty hilly around there off in the distance. And that's a 6-foot ladder standing in front of that gentleman in the hard hat. Any questions about this? Again, the solar arrays were engineered for this area.
If you want to answer this one quick, have you had any wildlife damage, rodents, coyotes?
Well, not the only damage per se we got was from birds. And basically, the birds do what they do best. If you have been in the city where there are a lot of pigeons, you can see the results of what they do best on the sidewalk. And basically, they have to go out periodically and wash the arrays down, as well as at the top of the array where the birds would normally sit, they stuck a bunch of vertical metal pins so that they could not light on those points, because it seems like every time they take off or land, they go to the bathroom. And that's about it as far as, oh yeah, we had one cow pull on the guy wires of one of the poles and pull it down. Don't know how exactly they did that, but in any case, the cow, I guess, had some minor damage to itself, and of course it bent the pole pretty well, and so the pole had to be basically replaced, and same antennas moved over to the new pole, but that was not the extent of animal damage per se. No rodents. Everything was well sealed. You know, it's designed for that weather, and the solar array is designed for that particular location, and it performed very well. The customer was happy with it.
Thanks, Nick.
You're welcome.
Okay, so a blitz to the end here. Just put a few images up. This is northern Wyoming, and it's along a pipeline for monitoring control and emergency shutdown. And that's standalone, no generators involved. They're relying on this particular system. And the next one is, oh, and by the way, the communications that would be involved there, it's radio frequency. Just talking about the mesh that Nick described. And the next one, that's the obvious one, big microwave repeater there, and that's what it's powering. This is Mojave Desert. And this system is hybrid. The gensets are behind those sonotubes that the power stations are sitting on. You can see the propane tank over just on the edge, the right-hand edge of the picture. And the idea here is it was very remote, and they couldn't bring there's times of the year when it was hard to get propane in, and they would have to bring a lot of propane in. So hence the big arrays coupled with the gensets. So next on that is this is the way we communicate the site location and the loads and how we define the loads, voltage, current, or watts, and duty cycle, voltage tolerance, all that. When that's defined, we know exactly what you want. And that's also next available on the website along with a host of information.
Right, we got a great download center set up for people. You can find the product data sheets there, engineering bulletins, worksheets, mounting solutions, industrial components, lots of good stuff there. So if you get a chance, take a look. Okay.
So the blitz is over, and we're at the end of the hour here, but we're here to answer the questions. I'll leave it there.
Yeah, let's go back to the one that was asked about, a rule of thumb, set of guidelines. when determining a budget. So talking about costs for solar and telecom systems, maybe you can quickly include in that, lead times, that kind of thing. Each of you, is that possible?
Yeah, sure. We can. It's on the solar side of things. By the way, we have a engineer bulletin that's on the website in that information center that gives you some of those rule of thumbs. But it's, there's a wide range of sites out there. You can have in the Pittsburgh area and then up through the Northeast, and once you get out to the Northwest, that December to January time frame is bleak, but some of our biggest customers are in just those areas. So it's from, you have that spectrum down into the Mojave Desert, of course, and the Southwest. So that all filters in. But so there are rules of thumb that allow us to say, okay, it's the array is going to be from this size to this size, and then that array size turns into a rule of thumb for dollars, a range of dollars you can do. But you can think from the smaller telecom when it's just a couple watts in most locations, in the range of $1,000, and then it just goes up from there. And it's proportional. So the loads are key. First you look at your loads, reduce those, make those the most efficient you can, and then look at that particular set of power requirements, and that'll translate. I'll leave it at that. Do you know who asked that question so you can send them?
Yeah, we can.
Okay.
And
yeah,
how about Nick, do you want to take a stab at that too? Approximate cost.
Yeah, I can jump in on the telecom side of things. Talking about radios, for example, you can get radios anywhere from a couple $300 to several $1,000s each. It just depends on, you generally get what you pay for. And if you're talking about long-term reliability, there are some companies that specifically are designed to work with solar in that they have some of the lowest current draws in the industry. And with respect to cell modems, you can get those for anywhere from $1,000 to $2,000. A one-year contract for a gig a year with some companies runs about $1,200. There's probably a $400 or $500 connect fee, initial fee, just like starting up a cell phone. And then you run, the longer your contract, the lower the cost overall, kind of just like the same thing with your cell phone. If you're talking microwave, it really is all across the map. You can get stuff that starts out at $1,500, or it goes up to $100,000, not counting the power. As far as lower bandwidth to higher bandwidth, and if you're talking towers, needing to put in towers, that can be a fairly expensive proposition. It needs to be done right, and the number of antennas you're going to stick on the tower and the wind loading on it are all that needs to be figured out in advance, plus how to get everything out there and what to do with it as far as how long you plan for the installation, whether you can do installation all year or only during the summer. There's a lot of factors that tie into all of that. Distance-wise, it's dependent on a number of factors as well, frequency and terrain, so on and so forth, and various clearances, and atmospheric effects on some frequencies. So
Nick,
that's
these
kind of
questions kind of relate to that. Maybe you can add on. One person is interested in knowing the low power draw radio options or brands, and then what lightning protection or grounding system is used to protect telecom and solar.
Okay. The low current draw radios that I've seen are from FreeWave technology. And on transmit, the highest I've seen is about half of basically 500 milliamps. And when they're not transmitting, which is only part of the time, most of the time they're in either standby or sleep mode, which will draw anywhere from 100 milliamps to maybe 200 milliamps if it's actively receiving. So those radios, those particular radios are designed with solar systems in mind. And they optimize things, of course. The less current that it draws, the smaller the battery system and the smaller the array size you will need. in order to make that happen. So, and the second part of that question, Marcia?
Is about lightning protection and
Okay.
grounding systems. Protection.
Yeah, years ago there was a very excellent manual put out by Motorola called the R50 Grounding for Telecom, and it's still available online. I was able to download a copy once I found it. It's just called the Motorola R50 Manual, and that goes into more information about putting together telecom sites than probably most of us have time to read. But basically, you need a good ground system. By a good ground system, multiple points, if you measure it, the ground needs to be less than 1 ohm to be a very good ground. The antenna support structure needs to be grounded, as well as the portion of the antenna that is designed to do that, and that will account as well as having good lightning protection from either transector, polyphaser. There are several companies out there that provide good lightning protection. There are a couple of different kinds. One of them uses a gas tube that is replaceable, and that's a pretty good solution. And the other one is more of a permanent device, but it's able to take a number of strikes, lightning strikes. But in all honesty, in the final analysis, if the lightning god wants to get your equipment, there's really not a whole heck of a lot you can do to stop it. It's going to find a way in. You can put all the lightning protection and everything else you want on there, and it does help in most cases, but in some cases it doesn't matter. Lightning is going to get through. Having good grounds is about your best protection, and I've seen people put up various lightning catchers, pointed type spikes, arrays, and whatnot around the antenna made out of metal, and as long as they're not interfering with the antenna, as in they need to be above the antenna and up high enough to where they're not going to distort the antenna pattern coming off the antenna, then they have some chance of working. But it's kind of hard to do that and then bring it down next to the antenna, because that metal will change the antenna pattern a little depending on how much metal it is in order to do that. So it could be an insulated pole too with a metal cluster, spike cluster on top. But again, ultimately, if lightning wants to get through, it's going to do it.
Yeah, it is, and that's we take our cue off Nick's side for the telemetry equipment on how he grounds it. I believe it's usually isolated from the power supply coming in, and we ground the frame of the solar array down through the down to the ground through our, and we ground the metal on outside of our battery enclosure, and that's grounded. Electrically, the battery is the negative side of that generally is not grounded. There's protection, and for the reason that on a nearby lightning hit, the transients will come back up through that ground and hurt the electronics on that. But on our system, the controller itself, I saw that question about about controllers. Morningstar is an excellent manufacturer out there. They have very, very few. Well, they're well protected electrically, and very few failures come on. It's like when there's a question about the controller, it's usually more of a question about a load that was out of control and pulled the battery down and to a level where the controller can't operate. But Morningstar would be my recommendation as we integrate those controllers into the system. Yeah, and they also, I saw the question on about monitoring through the controller. And again, Morningstar in their maximum power point controllers, the larger ones, offer access points for monitoring with the load and input through the array, and everything to do with the health of the power system.
The Morningstar has a very excellent algorithm for that, been developed over a number of years, that allows them to optimize the power charge and whatnot as a result of that algorithm.
Okay, great. So we have a few more questions here, but I am going to take those offline with David and Mike and wrap it up, not keep you guys too long, all of you. And just want to say thank you to everyone for coming and these really excellent questions. And thank you, Nick and Charlie, for the valuable information and engaging discussion that we just had. And everybody will receive a copy of this recording this week. And we truly all look forward to working with you on your power projects. Thank you again.
Thanks, Marcia, everybody. Nick?
Thank you very much, and thanks everyone for coming. I know it's difficult to take time out of your busy day in order to do these type of webinars, but hopefully we provided enough information for you that will make it well worthwhile. And thank you, Charlie and Marcia.
Have a great day, everybody. Bye-bye.
Yep. Bye-bye.